Hi, I'm Debbie with Nixene Publishing, and we are continuing our series about graphene in a little bit of a different way today. We're starting a different kind of approach, and what we're going to do is have Adrian answer your questions, the questions that you've left in the comments on the videos that we have produced for you. All right, we'll move on to an interesting one that is about the space elevator video that we just did, number 41. If I recall correctly, in the CVD process, the method that is used to pull apart the graphene from the copper involves dissolving the latter with acid. Could it be made instead by inducing a negative charge in the side of the copper that is in contact with the graphene? Would that repel the sea of electrons and thus the graphene sheet?
What a clever idea. In principle, yes. So basically what the question is referring to is you're making graphene on copper foil. I don't have the sample here, but you've all seen it in previous videos. And it's how do you get the graphene off the foil in the first place? And so what the question is saying here is, if that's the copper then, and the graphene is on here, can you treat the copper somehow that you get an electronic charge here, which is negative, and the graphene has a negative charge on its surface there with all the electrons, so the two negative charges repel each other and away it comes. It's a really neat idea. Nobody's done this. I think Northwestern University might have played with this a long time ago, but my guess is that probably, if they did make it work, it was on a very small atomic scale. The problem is, how do you get that charge into the copper in a coherent way? And is it strong enough to lift apart? So I have to say, don't know, really clever idea, really good thinking. I haven't seen anybody really tackling this seriously, but interestingly, getting the graphene off the copper foil is the biggest challenge on CVD manufacture, roll to roll. There's only one company really who's seen, two companies have cracked it, one at batch level and one on a roll to roll, but they're both peeling it off with something else. So yes, probably a good idea that's worthwhile exploring further.
All right. Well, thank you to the person who sent that in.
Yeah.
And let us know if you have any other leads on people that are working on this. We'd love to hear about it.
Yeah, and I'll look into this as well afterwards.
For today. So thank you so much for letting us put you on the spot. And it was great answers and really great feedback from our viewers. Thank you so much to all of you. And please continue to watch and subscribe so you get to see our videos first before they make it out to our social media channels.
And if I've made any mistakes, tell us. We'll come back to you.
Yeah, absolutely. All right. Thanks so much for your time, Adrian, and we'll see you next time.
Thanks, Debbie. Pleasure as always.